Hello, students! In this video, we're going to explore the fascinating world of acids and bases. Let's start with acids. Acids are known for their sour taste. Some acids have strong smells. For instance, acetic acid, which gives vinegar its distinct aroma, is easily recognizable. Acids come in different states: liquids like hydrochloric acid, solids like citric acid, or gases like carbonic acid in sodas. When acids dissolve in water, they break apart into ions. For example, hydrochloric acid splits into hydrogen ions and chloride ions. It's the hydrogen ions that give acids their sour taste and other properties. In water, these hydrogen ions quickly form hydronium ions, which are crucial for understanding how acids behave in solutions. Acid solutions can conduct electricity because the hydrogen ions move and carry electric charges. Many acids are also corrosive, meaning they can damage materials like metals and even skin. This property is useful in various industrial applications, such as cleaning metals. On the pH scale, acids have a pH less than 7. The lower the pH, the stronger the acid. For instance, hydrochloric acid has a very low pH, making it a strong acid, while weak acids like acetic acid have a higher pH. Acids can be categorized as strong or weak based on how completely they ionize in water. Strong acids fully split into ions and have a high concentration of hydrogen ions, making them highly conductive and having a low pH. Weak acids only partially ionize and have a higher pH, producing fewer hydrogen ions and less conductivity. Acids can be either concentrated or dilute. Concentrated acids have a high amount of acid and a low amount of water, making them very strong and potentially hazardous. Dilute acids with more water mixed in are safer to handle. Now let's talk about how acids react. When acids come into contact with metals, they often produce hydrogen gas. For example, hydrochloric acid reacts with zinc to form zinc chloride and hydrogen gas. Acids also react with metal carbonates to produce salt, carbon dioxide, and water. A reaction between sulfuric acid and calcium carbonate results in calcium sulfate, carbon dioxide, and water. Similarly, acids react with metal hydrogen carbonates to produce salt, carbon dioxide, and water. For instance, sodium bicarbonate reacts with hydrochloric acid. Acids can also react with metal oxides to form salts and water. For example, copper oxide reacts with hydrochloric acid to create copper chloride and water. In a neutralization reaction, acids react with bases to produce water and salt, like when hydrochloric acid reacts with sodium hydroxide to form sodium chloride and water. Moving on to bases. Bases often taste bitter, though tasting them is not advisable. They have a slippery or soapy feel, which is another way to identify them. Bases turn red litmus paper blue, helping us distinguish them from acids. Bases can be solids, like sodium hydroxide, or liquids, like ammonia. When bases dissolve in water, they produce hydroxide ions. Sodium hydroxide, for example, breaks down into sodium ions and hydroxide ions. Like acids, bases can conduct electricity due to the movement of hydroxide ions. Bases that dissolve well in water are called alkalis. They form clear solutions and have a pH greater than 7. Some bases don't dissolve as much but still have basic properties. Bases can also be strong or weak. Strong bases like sodium hydroxide and potassium hydroxide fully ionize in water and produce a high concentration of hydroxide ions. Weak bases, such as ammonia, only partially ionize and produce fewer hydroxide ions. Bases react with acids in neutralization reactions to form water and salt. They can also react with active metals to produce hydrogen gas and a metal salt. When bases react with ammonium salts, they produce ammonia gas. Additionally, bases react with non-metal oxides to create metal salts and water. Bases have several practical uses. Sodium hydroxide is used in soap production and paper manufacturing. Calcium hydroxide is used to make bleaching powder, while magnesium hydroxide serves as an antacid for stomach relief. Sodium hydrogen carbonate, or baking soda, is another common base used in baking and as an antacid. Finally, let's discuss the pH scale. The pH scale measures how acidic or basic a solution is. ranging from 0 to 14. Maintaining the right pH is essential in various fields, including digestion, agriculture, and water quality. It affects how we digest food, how plants grow, and even how aquatic life thrives. Indicators are substances that show whether a solution is acidic, basic, or neutral through color changes. Natural indicators like turmeric change color in basic solutions, while chemical indicators like phenolphthalein provide precise pH measurements. A universal indicator can give a broad range of pH values and change color accordingly, red for very acidic solutions and blue for basic ones. That's our journey through the world of acids and bases. Attempt to answer this question next. What type of ions do acids produce in water besides hydrogen ions? Share your answer in the comments. The complete curriculum for Class 10 is available on our channel. Check out all the links provided in the description below. Please make sure to like, share, and comment for more such videos.